Hey guys, what's up? Eddie Yahoo here with KissAnalog.com. Today we're in the lab with PicoScope. Again. Okay, so first I want to remember to say Pico Technology sent this out to me for free. It was really cool of them. I thought I was going to get a demo version, but they gave me one to keep. That was super neat of them. Now, I picked out this differential mode, which by the way, this 4000 series is a 4444. Has 4 differential inputs. So I just did a review video, which this one kind of works with that one, okay? So this video kind of goes along with the first video. It shows the setup. I did a test on the other one. I didn't really show the setup. In this video I'm going to show the setup. I'm going to show the cables that came with it. I'm going to take some measurements of the cables to kind of show you the high impedance isolation of them. And yeah, just kind of show you some things that would have made the other video too long, okay? Super cool scope. Let's jump into it and open up this box and show you what came with all this stuff. Alright, so this is the case. This is the scope. You see the USB port here. The 5-volt power input and the calibration connections. There's both a plus and minus. It doesn't show ground because it's differential, right? And these two guys are showing that they're tied to chassis ground, which is this guy, which would go to your earth ground connection. And then there's our 4 inputs for our differential. Okay, 9-pin. And there's a LED right here, looks like, that'll come on. And right down, yeah, right here you can see the ratings. 46.7 volts peak max, that's at the input here, plus minus 50 volts. So if you have a ×1 probe, that's what you got to have at your end of your probe. But if you have a ×10 or times 20 or 100, you can have higher voltage signals, of course. So right here, 12-bit, 400 megasamples per second, 14-bit, 50 megasamples per second. 20 megahertz, 256 megasamples. That's really deep memory, 4 differential channels. And our power cord. Now this guy clips like that, and it comes with, okay, our little plug there, and it comes with, let me see, a bunch of different connectors. There's that one plastic, and then the 2 metal tips. Bunch of Euro stuff. And that guy. What else? And this one. So you have 4 different types of power adapters. These spots here are for the higher voltage differential probes, the ones that I hope to get someday soon here. And I guess this is where all the cables and everything goes. So split here. And then I'm not sure what this little slot is made for. Maybe some kind of probe. I'm not sure. Okay, and then we have our quick start guide. It's just in a pocket here. It's just snapped in on this plastic right here. You just pull these tabs down to unlock it. Flip it over. Okay guys, I brought this back out. The first thing I want to show you is the cable, because I kind of sped over this when I was showing you this. I didn't really point it out. But if you notice that large USB connector, that is a USB 3.0 connector, and it's just a bigger connector, right? It's meant for higher speed and a little more power, okay? So this is a USB 3.0. It even actually says it right on the cable. It says super high speed 3.0. Okay, so you might notice that it's a larger gauge than this really nice USB cable, the standard USB size. It's still even bigger than that. Now this is the standard USB, and this is the 3.0 over here. So that it adds extra pins, gives you more speed and more power. Okay, so 5 gigabits per second is what I think the speed of this guy is, which is should be 10 times more than what the old USB style gives. All right. Okay, so the other things we get in this is D9 BNC adapters. Okay, let's just pull this open. All right, that's cool. We get 2 of these. So now each one of these plugs into the differential input, and you can put your normal type scope probe, your single-ended scope probes on these. Okay, so there's 2 adapters for that. So there you go. You can use your times 10 probes or times 100 or whatever you have. Okay, then, or even current probe, right? Okay, then what we have is same thing, but in this case we get a plus and a minus probe. So you can use standard probes or whatever, and each one would be you know, a single-ended probe. Your grounds would go together, but it'd give you a differential reading. So you got, those are super cool. Now here are the probes, the times 1 probes that you can use to plug into those. Wow, okay, that's cool. You know, at first I didn't see these in the bag, but oh, that's awesome. God, I thought I forgot to order those, but yeah, those are nice, like banana to alligator. Those are actually really nice ones. Man, I'd like to have more of those. I like the round spring clip instead of those real flimsy, weak springs, but it has a nice actuation feel. Okay, cool. Man, I could see through the bag, I could see the probe, but I couldn't see those, so it had me worried. I thought I was supposed to order those separate. Okay, rip open this guy. Sweet. Oh, okay, we don't even need this. This is to hook your normal probe. So yeah, with this one, it comes with its own input, and then you have your plus and minus output. Sweet. So, and then our ground clip. So if you compare that to this, you'd have your red probe, your black probe, and then the shield on each one of these would be this guy. So if you used your normal probes, that's kind of how you would hook them up. Wow, that is neat. Wow, these are interesting. These are just a solid round. Wow, that's interesting. It's a solid round shaft with 1 heavy-duty spring. Wow. Okay, that holds on tight. I like that. Okay, those are nice. Oh, look at that. That's cool. So you can stack them too. That's really neat. So if you have let's say you have 2 grounds or 2 probes you want to put in the same connection, wow, you can stack them. Oh, man, I'm really liking these. That was a smart design. Okay. Plus. All right, guys, look at that. In case the colors didn't work for you, you got your chassis connection, your plus, and your minus. All right. It's marked on both sides. Sweet. These are, wow, okay, I can feel the rubber tension. I mean, so that's nice. It's nice and soft. Okay, man, can't wait to use this guy. So we should have, that's a PQ-098. And another name for this is the Pico Connect 441 differential 1-to-1 probe. Okay, so it's, I think, often referred to as a 441. So the PQ-098, I think is, I don't know, I guess it's the actual part number. So there we go, we got 2 of them. Now I have 4 channels, right? So it'd be nice to have 4 sets of these if I wanted to go all 4 channels with ×1. But what I can do is I can use these in 2 channels, use those in 2 channels, or these, or combination, mix them up. Now when I get the other probes, the high voltage differential probes, these are ×1, right? I think the other ones are ×20. So when I get those probes, I can put 2 of those in 2 channels and use these 2 in another 2. Okay, I was just looking, it says it is a UL marking, a CUL. Just trying to see what other current markings are on this cable. Okay, that's interesting. 124 ohm. Twin axe. That's nice. Each one of these guys is shielded inside here with this black shield here. So it's a Belden 9271. One pair 25 shielded UL. Okay, there's all the information in case you're interested in that. Made in the USA, I guess. Okay. Alright guys, just to verify that this shield right here is tied to chassis, just to ohm it out. And that does show, that line is showing that. It also shows that it comes over here. But when I go down and touch the minus terminal, I get 220 ohms. So if I touch either one of the terminals, or both even, it doesn't seem like it's tied to this guy. So now there is a shield. This shows the plus and minus and kind of a shield around it. So maybe there's a shield around the power that's tied to chassis, but the power itself is not. And then the minus pin over here looks like it's tied. So, okay, that's interesting. So if you tie this to chassis, you can tie your minus and your shields to chassis, but the power still looks like it's isolated from chassis. Or once you tie that to earth ground, you know, it still looks like it's isolated. Although the minus pin is not. That's interesting. Okay, so just take that a little bit further. If I come over here to the minus, to the chassis connection, and touch the shields here. So it looks like the shields in front are all tied to chassis. So if you want those shields tied to chassis, then you tie that thing to chassis. So yeah, it looks like all your shields for your cables are tied to the chassis, which is all those shields which you would tie to earth ground, your protective earth ground. But again, that's just your shields being tied. Your input connections are still isolated, essentially isolated as differential probes. Alright, so just to demonstrate this, I've got the blue on each probe. I've got probe 1 and 2 plugged in here, okay? And I'm going to the multimeter, and we got about 2 mega ohms between those. And even if I go to the positive one, about 2 mega ohms there. So yeah, the probes, you've got about 2 mega ohms impedance between any of the tips, so they're essentially isolated, high impedance isolated. Okay, so you got differential probes here, not connected to each other, so you don't have to worry about connecting your blues to the same channel and all that. Now the black is the shield, so if we go to the black one, they will be tied together. But from black to, let's say from black to blue, one of the blue ones, you still have that mega ohm impedance, okay? Okay, but then if we take the grounds of each probe, tie them together, then they're, you got some impedance to the cable, but basically that's your shield, that's the other end of your shield. The jacks up here was the input, tied to chassis, and these wires are going back through this cable. Back here, you get about 0.2 ohms. And just for your reference, if I put my scope probes together, it's about 0.06. So just a little bit of impedance, but yeah, your blacks are just your shield, okay? Your other end of your shield. And from the end of the plug here to this plug, it's about 3 feet. So roughly a meter. It's a little, it's 3 feet, okay? And then the length from there to these, you can see about 5 inches, 5.5 inches maybe. 14 centimeters. Alright, just for fun, I thought we'd use the generator here, Unity generator coming into the channels. I've got both channels hooked up right here, channel 1, channel 2, and I've got them both connected to the generator. So from the generator, the plus and minus, I put channel 1 plus and minus 2. Channel 2 I reverse the leads just to show you they're both differential. It doesn't matter which way you hook them. And then I just tied the 2 ground shields together for this one test. Okay, so let's just go up here and I'll show you what it's going to look like. Alright, now when I come up here and I've got PicoScope 6.0 right here, you see it coming up. And it actually comes up pretty darn fast, I think. Here, relays clicking on, and there's both channels right there. So it looks like it automatically kind of sets up as it comes up. And there's a little window over here saying probes are connected, just telling you that they are actually connected. So here, let me blow up the window here. So yeah, that's what it looks like. Let's zoom in on that. Alright guys, so what do you think of this? Pretty darn cool, huh? I mean, that little thing is packed full of power. Yeah, you're not paying money for the power supply to run the display or all the CPU and all that. It's all built into the laptop, that part of it. So this is just the front end, and to me it looks really capable. Hey, I want to thank Pico again for sending it out. That's really awesome. Appreciate it. I want to thank all my Patreons. Really appreciate you guys. And you become a patron for as little as $1 a month. Just toss that out there. And I want to thank everybody for watching the videos. Oh, and give it a thumbs up. That's a free way to help the channel. Appreciate that. It helps YouTube analytics and all that stuff. Really does help the channel, actually. So, hey guys, right now I have this powered just through the USB to the computer. I'm not using the little power cable wherever it went to, this guy. I found out that depending on the probes, the kind of probes you have, now maybe if you have a bunch of active probes on it, then there's enough power that you want to use this guy, but otherwise it just plugs and gets powered directly from the laptop. So that's really cool. This is a MacBook, so it has an OS operating system. Right now I pulled up the OS version of that software. In the last video I was running Windows. It's running on Parallels, a Parallels program that runs on Mac. So you can run all the Windows type stuff, and it runs seamlessly and just as fast as it does on a PC, as far as I can tell. Right now I've got 8 windows open. I mean, this thing's crazy. I thought the limit was 3. It said something about 3 windows, but I've got 8 windows, and I could hear the laptop kick on. The fans just kicked on when I had all this stuff, so it's taking a lot of power too, maybe. I don't know. Fans are going off now, so maybe it's just getting kind of warm sitting up here. But anyway, man, I got a Spectrum down here and then a bunch of 7 scope channels, and they're just all duplicates because I only got just one signal. But anyway, I mean, look at the screen size of this compared to these screens. So yeah, you can see so much more detail. It's so much more clarity on a big. This is a small laptop. This is 13-inch. So man, I'm impressed. I can't wait to use it more. I've actually started my next video. I've got this little buck converter on here. That's another series that I'm doing. And yeah, I just started playing with that. And I'm, so far, like I said, I'm just really impressed with this. So, what do you guys think? From the last video, I could see a lot more people using Picos than I was kind of surprised, actually. Okay, I got to be honest. I never really thought too much about these USB type scopes. I think it's because in the old day, back when you could get these cards that were, you know, like a scope on a card or a Spectrum on a card, you'd put them in the big old computers back then in those days. You know, I was never really impressed with those specs. I was trying to look for an affordable thing to use at home, but you know, the bandwidth, the vertical rate, there's just nothing really that impressive about them. On this guy, with, you know, the deep bits, I mean 12, 14 bits and that, even, you know, hey, one thing I want to throw out there is even their low-cost model, I think the $130 or whatever it is, under $200 models, they're 8 bits, but they have a high-res mode where I think they go up to 12. So that's just incredible that even on an inexpensive scope you can get that. So anyway, alright guys, thanks for watching, and you know, I'll put a playlist with the Pico stuff, so if you want to see any stuff that the Pico can do, I'll compare it to this GW Instax. It's a mixed domain scope with the Spectrum portion. So we'll compare the spectrum analyzer portions of these two scopes. Really excited about this. So yeah, let's do more videos. We'll see you next time.